Hi everyone, let's continue with sp3d2 hybrid. Let's see the example of SF6. So you have the Lewis structure and this is the electron. You will have the total of electron. The total of electron here will be 48 electron. And then the structure of SF6 will be like this, the Lewis structure, and you can see here the sigma bond is there are six sigma bond, so means the bonding pair here will be 6 and then no lone pair, therefore the total of the electron pair will be 6 electron pair, and this one will be sp3d2 hybrid. And this one will be class AB6, and this geometry here will adopt the shape of octahedral. For the third step is you need to write the orbital diagram for valence electron untuk sulfur, the central atom, and you will have you will have 3s2, 3p6, and you can see here from the Lewis structure you will form 6 sigma bond, means here you need to have 6 single electron. So if you can see here, kamu ada 2 of them in pair, therefore you need to excite each of the electron into the empty d orbital. The excited state will be like this, and now you will have 6 of the single electron and all of them will be hybridized, and it will be sp3d2 hybrid orbital, and the rest of the empty d orbital will be 3d unhybrid orbital and they will remain empty. And for the terminal atom, you will have it as 2s2, 2p5. And you will have one single electron here ready to be bonded with sulfur. Next step is draw, and this is the drawing and the overlapping for SF6, and make sure you need to label the hybrid orbital correctly. As you can see here, the one in for sulfur I highlight in yellow, it should be sp3d2. The labeling, each of the orbital must be labeled, and you must at the overlapping or the sharing of electron here, you need to label them as sigma bond. And don't forget to label fluorine atom at each of the 2p orbital. And last, you need to state the class of this SF6. It should be AB6 since they are no lone pair. So the molecular geometry will be octahedral based on the basic shape, and the bond angle here will be 90 degrees. The next example is XeF4 and the Lewis structure. There are 8 valence electrons for xenon, and then for fluorine you have 7 times 4 of the electron, and because you have 4 fluorine atom, therefore the total of the electron will be 36 electron, and you distribute all the electron to form this form of Lewis structure. Okay, so before you come to this structure, up to you, you want to draw according, yang penting octet, satisfy octet rule untuk all the terminal atom. And then for the central atom here, you have xenon. So for xenon here, untuk xenon, it is the central atom, and for xenon, since it is in period 3 and above, therefore it can be expanded octet. Okay, why I choose to draw in this Lewis structure, because later it will be easier for me untuk draw the overlapping of the sigma bond. And ini I've already drawn it according to the molecular geometry. Okay, so for step 2, to predict the hybrid, the bonding pair of electron will be, ini dekat sini ada berapa sigma bond? So you have 4 sigma, and then you have 2 electron pair, 2 pasang, and then the total electron pair, berapa pasang of electron there, will be 6, and you can predict the hybrid of the central atom will be sp3d2 hybrid. And this one will be ini untuk dia punya electron pair geometry will be AB6, and this will adopt the geometry of octahedral. Okay, so yang ini tak penting, yang these two. Yang penting for this part adalah you predict the hybrid, and these two hanyalah untuk guide kamu for the step number 4, which is you need to draw and show the overlapping of the sigma bond. So next is you need to write the orbital diagram, and you just need to focus on the central atom, which is xenon. For the ground state of xenon, you have 8 valence electron, and it will be 5s2 and 5p6. And you can see from the Lewis structure, you will have 4 sigma bond, and then you will need to have 2 lone pair. Therefore, dekat sini, 2 of the electron akan excite masuk the empty d orbital. So, your excited state of xenon will be 5s, 2 electron, 5p, this orbital, 2 single, and single electron. Okay, so another 1 electron. Okay, so double check your electronic configuration. Ni lone pair, ini untuk lone pair. Sigma 1, 2, 3, 4. Okay, next is the hybrid state. So this hybrid you already predict before this. It will be sp3d2, and there will be 6 of them. 1, 2, and label the orbital. Okay, so here will be sp3d2, and the rest of this will be 5d unhybrid orbital. And then for fluorine, it will be 2s2 and 2p5. Okay, so next, the drawing of XEF4. So make sure you draw the Lewis structure here first. Okay, yang penting kamu ada this Lewis structure. Okay, ini akan jadi guideline for your drawing to show the overlapping to form the sigma bond. Okay, so make sure you label all the orbital, and for xenon you have 6 orbital, the one in black, and then make sure you label sp3d2 for each of them, and 2 of them adalah lone pair. So untuk lone pair ni kita akan susun the electron sejauh mungkin. So kalau in this geometry octahedral kan, kita boleh susun dia di bahagian atas dan di bahagian yang totally opposite. So the one in planar akan remain lah sebagai bonding pair. And then untuk fluorine, make sure you label 2p orbital because the single electron is in 2p orbital. And when you do the overlapping, don't forget to label sigma bond. This one, 1, 2, 3, 4. So you have 4 sigma bond. And then the class here will be a B4, E2, and then the molecular geometry will be square planar. And the bond angle ini hanyalah between XE. Untuk ini sahaja. Untuk XE, that bond with fluorine with another bond. Okay, so bila kamu tengok bond angle, it is between bond lah. Okay, yang mana between bond. So all of the angle will be 90 degree. Okay. For the hybridisation of ICl2 minus, so you will have here 22 electron in total. So your Lewis structure should be like this. And for the central atom, iodine atom, the bonding pair will be 2, and there are 3 lone pair here, so the total will be 5. So from here, 5 total of electron pair. Ini akan jadi hybrid sp3d. So the total of 5 new orbital that you form, and all of them are sp3d hybrid. And for this case, dia akan adopt geometry of electron pair geometry. Dia akan adopt trigonal bipyramidal. So the next step is you need to write the orbital diagram. So untuk the Lewis structure, since you already assign the formal charge, negative formal charge to the iodine atom, and here instead of iodine, normal iodine atom, you have 7 valence electron. And sepatutnya biasanya kita akan tulis ground state-nya adalah 5s2 and 5p5. Okay, total 7 valence electron. But untuk iodine, I minus ion, okay, this one, I minus akan ada 8 electron because you have 1 extra electron. So dekat sini, the ground state will be 8. Okay, so untuk yang melibatkan charge, kalau molekul tu ada charge, it's just bila kamu buat Lewis structure, yang penting assign the formal charge. And then untuk the third step, which is orbital diagram, kamu mesti tulis untuk ground state for the ion. ataupun yang ada extra electron ataupun less electron tu. Okay, whichever either positive charge ataupun negative charge. Okay, so for iodine, you have 2 sigma bond and 3 lone pair. So double check here. Means dekat sini, one of the electron will be excited into the empty orbital, and then you will have it here. Okay, so you will have 3 lone pair and 2 sigma bond here, and then the hybrid state of I minus. So just rewrite the hybrid that you predict before this, and then all of them will be sp3d hybrid orbital, and then the unhybrid will be this, the one that left empty. And then for chlorine, the ground state of chlorine will be 3s2 3p5. Okay, so the drawing will be like this, and don't forget to label each of the orbital. sp3d, you have 5 of the orbital, so label kelima-limanya, and 3 of them will be lone pair, 1, 2, 3, and then your overlapping with chlorine, you will form sigma bond, 1 dan 2. Okay, so label next to the overlapping. And then don't forget to label the atom. And last, you need to write the class based on the drawing. It will be AB2E3, and this one will be geometry linear, and the bond angle is between ICl with and the bond angle is between the bond between this ICl and with another bond of ICl. So the bond angle here will be 180 degree lah. The next example is PF4 minus. So when you draw the Lewis structure, you need to include here the extra electron because this is negatively charged, therefore you need to add 1 electron. And then when you draw the Lewis structure, kalau kamu nampak ada 4 bond and 1 lone pair here, so kamu boleh terus lukis dalam bentuk dia punya geometri. Okay, so for this one, dia akan jadi bonding pairnya adalah berapa? 4 sigma bond, and then you have 1 lone pair, so the total will be 5 electron pair. And for this case, dia akan jadi sp3d hybrid. Okay, so untuk electron pair geometry, dia akan jadi AB5, and it will adopt because you have 5 total of the electron pair. Okay, so bila ada 5, dia akan adopt shape of trigonal bipyramidal untuk drawing the hybrid later. For the next step untuk orbital diagram, for this structure PF4 minus, you need to do a bracket here and negative charge, and you need to calculate the formal charge on each atom. So untuk fluorine, all of them adalah zero formal charge because 7 valence electron untuk fluorine minus 7 electron around the fluorine atom. So kamu akan dapat 0 for each atom fluorine ni. Untuk Untuk phosphorus, okay, ini the valence electron 5 tolak 6 elektron around phosphorus, kamu akan dapat negatif 1. So the negative formal charge belongs to phosphorus. And then untuk phosphorus, actually you have 5 valence electron. Tapi untuk this case P minus, you have 6 valence electron. And when you write, it will be 3s2, 3p4. So, referring to the Lewis structure, phosphorus ada 4 sigma bond, and then ada 1 lone pair. So, one of the electron here will be excited into the empty 3d orbital. And then for the hybrid state, kamu akan hybrid all the orbital, and then you will get the hybrid orbital, 5 of them, 1, 2, 3, 4, 5, and all of them adalah sp3d hybrid, and yang kosong ini akan jadi 3d unhybrid orbital. And the ground state for fluorine, it will be 2s2, 2p5. And the second last step is draw. When you draw, make sure you label the orbital. Ada 5 hybrid orbital, which are 1, 2, 3, 4, 5, and all of them adalah sp3d hybrid. And don't forget, bila kamu label sini, make sure you label dia adalah sigma bond. And label the atoms, phosphorus and fluorine. Okay, and for this case, don't forget to write the bracket lah, because you have the charge. Okay, so draw a big bracket here, and then assign the charge. For the last step here, the class will be A, B, 4E, because you have 1 lone pair here. And then the molecular geometry here will be seesaw. And the bond angle dekat sini akan jadi less than 90 degree and less than 120 degree.